Happy Friday, Math 96. Happy last day of April, Math 96. When we come back, it will be May. Okay, so we're going to go to notebook page 108 for quadratic functions and their graphs. And we are just going out of order now on our pages, so don't cross any out. It's just that I want to skip ahead to page 108, and then we're going to come back to some of the other pages, okay? So the essential question at the top of page 108 is, what is the formula needed to start the t-chart for quadratic graphing? And by the end of this lesson, you should be able to say that you can use negative b over 2a to find the middle starting value for a t-chart to graph a quadratic. Please, I want all your triad number 6 assignments loaded and done up to the digital workbook, okay? Please get that done this weekend. I'll be grading again. Okay, so this is in the top box. I kind of split it up, so I don't have the full box here. I'm going to just do it over the course of a couple of slides here. So this is the steps to graph if you were in standard form. So the function would be f of x is equal to ax squared plus bx plus c. So you need to find the location of the numbers for a, b, and c. And so a is always in front of x squared, the b is always in front of x, and the c is your constant, the number in the back. Okay? So that's how you find the location of the numbers that we need. All right? So remember, c is just a constant number. So if we find a, b, and c on our example, so this is the one we're going to use on the top box example, and we're going to graph this. So this negative 2 is a, this negative 4 is b, and this positive 1 is c. Okay? Now, there's just a couple things that you should know. If your a value, let me grab a pencil here, is positive, is a positive number, then your graph opens up, and there should be little arrows on the end of that. On the other hand, if a is a negative number, then your graph opens down. And there's always arrows. I just couldn't get a symbol that had arrows there, okay? All right, so that's the first part. So I'm just going to label A, B, and C again. Okay, so we found out the values of A, B, and C. Our next step is, well, let's go back. Hold on just a minute. So for this step, number 2, our A value is equal to negative 2. So we already know our graph is going to be going downwards. All right? All right, sorry about that. Now, step number 3 is to find the vertex. Now, the vertex of the graph, and we already know our graph is going to go down, is either the highest or lowest point. So right here is going to be our vertex. In this case, it's going to be the highest point. If our graph opened upward, then our vertex would be right here at the lowest point. Okay, but that's not the graph we're doing today. All right, so the vertex is the highest or lowest point. Let me just erase that. I can't seem to find my eraser. There we go. Okay, so for us to find that vertex point, because that's the most important point to find in the beginning for graphing for our t-chart, we use a special formula, and it's called negative b over 2a. Now, we already know the values of b and a, right? So we just need this formula, and what we're going to do is we're going to put our values right into here in the middle of our t-chart, okay? So let's get started finding the x, and then we'll figure out how to find the y, all right? Because we need the x and the y for our t-chart to plot our point. So the x value is going to be negative, whatever the b value is, and 2 times the a value. So this will be our b, and this will be our a, but I'm going to put the numbers in, not the letters. So let's go over here. Our b value is negative 4. I'm going to just change colors, okay? Our b value is negative 4, and our a value is negative 2. And then we just do the math, okay? And that'll be how much our x is. So negative 4 equals positive 4. And 2 times negative 2 is negative 4. And 4 over negative 4 equals negative 1. So that's our value. That doesn't work. Let me get a different color. Negative 1 is our value for the x. And we're finding the xy point of this vertex, okay? That's what we're finding. Okay, so now how do we find the y? To find the y, we plug in the x to get the y. Well, we plug it into our formula over here. So we want to find f of negative 1. That's the x value, right? Our x value is negative 1. And we're just going to write this down. And I put parentheses every time there was an x, didn't I? So we're going to plug in negative 1 for the x. And that will give us our y value. Remember, f of x is another way up here just to write y. So our y will equal. We went over that, remember? And hold on just a minute, I need to change my pen tip. Okay, so we're going to plug in negative 1 to the formula. And then we're going to do our math by hand this time, just to remember for PEMDAS. We have to do the exponent first before anything else. So this is one of the most common student mistakes, is they don't do this exponent. So you have to do the exponent first. So right here, negative 1 squared means negative 1 times negative 1, which would be a positive 1. So this comes out to be negative 2 times 1. And we're going to move on to this part. Negative 4 times negative 1 is positive 4. And then we're going to bring this part down and then just finish up. So negative 2 times 1 is negative 2 plus 4. How much is negative 2 plus 4? Just think 4 minus 2 is 2. And bring this down. Plus 1 equals 3. So our y value is equal to 3. Okay. I don't know, this doesn't want to seem to erase very well. What's going on here? Nothing's wrong, but oh well. Okay, you're going to have to just ignore it. I can't erase it. Okay, so you ready for the next step? I need you to read the box. You're going to now pick 2 numbers above and 2 numbers below the vertex for the remaining x values in the table of values. So we need 2 numbers above and 2 numbers below. So think about the number line. We're at negative 1 right here on the x values. If you go below, it's negative 2 and negative 3. So we're going to go negative 2 and negative 3. And if we go above, we're at 0, 1, and 2. Oh, sorry, we just need 0 and 1. Okay? So this is how you go ahead and you find the x values of your t-chart. And you know what? It's going to change every single time. The numbers that you use in the x values for the t-chart, it all depends on this equation. Okay? So now how do we find the y values? Now we just take each of these x's and plug it in. So I'm hopefully going to be able to use my eraser here. So we're going to keep plugging into this formula and doing the math, aren't we? So let's plug in. Let me grab a pencil. Let's plug in a 1 for x. So a 1 here and a 1 here. Do the math. Do the exponent first. 1 squared is 1 times the negative 2, right? It would be negative 2. Negative 4 times 1 is negative 4. Bring down the plus 1. Do the math. Negative 2 Minus 4 more is negative 6 plus 1 equals negative 5. So in our t-chart, we need a negative 5 when we plugged in a 1. Let's do it again. This time we're not plugging in a 1. And if you need a minute, hit pause. Hit pause on the video if you need a minute. Okay, now we're going to plug in a 0. Everybody loves 0. What's 0 squared? 0 times that negative 2 is 0. What's negative 4 times 0? 0. Bring down plus 1. 0 plus 0 plus 1 is just 1. Now watch what happens when we plug in the next number. Hit pause if you need a minute. Oh, darn, oh, good, it came back. I almost got rid of that on accident. Okay, so now we're going to plug in a negative 2. And watch what happens. Okay, so let's do the exponent first. Negative 2 squared is negative 2 times negative 2 is 4, times the outside negative 2 is negative 8. Negative 4 times negative 2 is positive 8, and bring down plus 1. Do the math. Negative 8 plus 8 is 0, plus 1 equals 1. What happened there? Look at this. These two numbers match. You're going to see on this that your bottom number is going to match this one. And that's the symmetry. It should happen like that. So let's plug in the next one. Try and get this number out. There we go. Okay, let's do the last one, negative 3. Whoops. Pick up my green here. Oh well. Negative 3. Negative 3. Can't seem to get rid of that pink that's in there. You guys okay with that? I just can't get rid of that pink highlight. There we go. Okay, let's do the exponent first. Negative 3 squared is negative 3 times negative 3 is 9, times the outside negative 2 is negative 18. Then do negative 4 times negative 3 is 12. Bring down plus 1. Start from the left always. Do these two first. Negative 18 plus 12 is negative 6. Plus 1 is negative 5, which, look, is the same as that number. That's supposed to happen. The reason that happens, I'll show you in just a minute as I erase this. And just give me a minute, okay, because I just want to kind of talk for a second. Remember, this graph is going to open down. This is the vertex. So if we were to plot this point, left 1 up 3, we would make that dot. If we were to plot this dot, 0, 1, it would fall right here. If we were to plot this dot over 1, negative 5, it would be here. And then if we were to go back and plot this dot, negative 2, 1, it would be here. Plot this dot, negative 3, negative 5, it would be here. So you see how there's dots across from each other? So these are the symmetry dots. That's why these numbers, the 1 and the negative 5, come up to be the same. Okay? It's the symmetry. So you'll see that when you plot the graph. I'm going to need to take a picture of that, I think, for the next page. So let me grab that really fast, just in case I need that information. So I think I will. Okay, let's move on to the next slide. Okay, so we had 1 to negative 3. And we also had negative 5, 1, and 3. Oh, I can't remember what this was. I think it was negative 3. Let me see. No, it was positive 3. Hold on, I made a boo-boo. I'll just make it a positive 3. Okay. I don't like that. I just want it to be 3. Okay. So here we are, finishing up your box. So now we're going to go ahead and plot these points. So this is the point 1, negative 5, over 1, down 5. This is the point 0, 1. Now kids have a hard time with that. For whatever reason, they have a hard time. So let's skip it for now and go to -1, 3. Left 1, up 3. Let's do the next one. -2, comma 1. Left 2, up 1. Last one. -3, -5. Left 3, down 5. Now you can see the graph. Watch, I'm gonna draw one side of it. And one of the things you need to do with quadratics is make the arc here, because this is never a graph that has a V. This is wrong. It has to be a smooth curve. Okay? So one way to help you with that is to just draw this little arc here and then swing it through your points. Now let's get back to this one that we skipped. 0, 1. Students often graph that wrong. They'll go over to this point, which is wrong. 0 means don't move, up 1. And you can see how it should be across from this point. All right. So sometimes the 0, the point with the 0 in it, it's helpful to graph it last. And then we're going to swing this down through this one. I missed. Not the easiest to graph on here. Okay. My arc is too big. My arc needs to be smaller. Okay. So smooth curve through your points. Now that is called a parabola. The shape of the graph is called a parabola. So you're going to hear me say that word. It comes from a quadratic function. And that means it has a power of 2, x squared. And we call this a parabola. And it either opens up or opens down. Ours opens down this time. Okay? We're going to be doing a project on this. So it's going to be important for you to get familiar with everything. All right. Now let me go on the next slide. So this is example 1. We'll come back to these examples on Monday. So please hold off on uploading page 108 until Monday. And like I said, we're going to skip around now a little bit in your notes. So don't be crossing out any pages. Just, leave them nice and ready to use. We're going to be doing some of your notebook pages out of order. All right, you guys have a great weekend. And please, I beg of you to get your notes and homework made up for Triad number 6 digital workbook. Please do that by Friday night. So when I grade on Saturday, everything's all updated, okay? Enjoy your weekend.